This is the homework for relative position. So I threw up there in case anybody had questions on that.
But you said that the homework until next time, no? Monday. Or it was until today?
Well, yeah, next time will be today for Monday. So we wrapped up relative position in class on Monday, and then you had exam corrections to do, and I said bring questions on relative position as well. And that's what this is right here. Did anything in here give you guys grief? Percentiles, quartiles, box plots, anything in there give you any undue grief? I know there's a bunch to do. I mean, you had a quiz plus this plus your corrections, but then again, that's why I make the quizzes optional, so you can just ignore the quiz and not turn them in if you don't want to. Plus you had the in-class quiz last time, and we'll have another in-class quiz today, which that works out pretty well, and I figured I'd put one of those together for class today as well. So anyway, anything in here give you guys grief? Oh, this is the answers, that doesn't help you at all. Well, maybe it does help you, just find the answers. Up here, we got some comparative box plots. We got some stuff out of the news. 29% of the poll responded on a credit card. Anything from text? What do you think the student on this road is? How did you decide? Yay. Anything? Solid. These clear as mud?
No.
No.
I just.
Oh, you just look at it. Well, you look at it. You look at it.
Yeah.
Email me questions when you get them. That's totally fine. Don't wait till Monday. Email me questions when you see them, and then we'll get answers back to you.
Because if I knew that it was for today, but.
Well, that's why, and that's the problem with on Tuesdays especially, or Mondays. Yesterday I uploaded the lesson, and I said, finish relative position, quote, bring questions to class next time. And that's the problem too, also with having classes that meet every 2 days or every 5 days, is that you forget that I say it, and you might not look at the schedule page. Or you might download the quiz, but in downloading the quiz, you forget to look up what we actually did that day, which says bring questions for next time. So decent for now, or at least neutral for now, I guess? Yeah, neutral for now. We covered it so well, or just look at it. Yeah. All right, so that's good. So we'll mute you down, all is well. Let's take a look. I want to share something with you. One of my favorite egregious BS uses of statistics ever. Let's see what we got here. We got our good buddy, my friend and yours. Yes. My friend and yours. Oops. My friend and yours. Apologize for the acetate versus PowerPoint outliers. So I like talking about Jared. We're going to go back to you guys guessing my height. We have to do that since we played with him last time, too. What does Jared have to do with outliers? What does Jared have to do with the topic of outliers?
He is one.
Your results may vary.
Good. Matter of fact, that's interesting, David. I heard he is one, which is true. This is what I did. I went ahead and checked their website about Jared because I was curious. And this is the text that accompanies it. So go ahead and read that, friends. Please note sentence 4. And then please note the website I pulled it from. And then please note the picture with the pants. So we don't endorse the diet he's on, but we're going to go ahead and use his image on our website with no mention. I had to dig. Look at the address. Subway.com ////. This thing is buried through 5 or 6 hyperlink clicks to get down to it. But Jared was on the front. So how can you justify, ethically, putting an outlier up and then saying, using that image as an advertisement? There's no good answer for that, of course, because it's not ethical at all. It's the same thing that happens with all weight loss programs. Every time they show you weight loss, one of my favorites of I shouldn't say relatively recently, it's been about 4 or 5 years since I've seen it now, probably even longer than that. This 50-year-old grandmother, blah, 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 and they show this woman getting out of a pool in a bikini, 50-year-old grandmother, and they keep talking about 50-year-old grandmother. At the bottom, the entire time they're talking, it's exactly the same caveat as that. Results atypical. Do not expect these kinds of results. But yet they've got this person who is clearly the exception, getting out of the pool, endorsing a weight loss program. this person who clearly is not even endorsed by the chain, being endorsed by the chain. This happens all the freaking time. And it drives me nuts. It drives me nuts because this is what drives commerce with this kind of thing. The Subway diet. They don't even endorse the Subway diet. But yet there it is. But there it is. So pay attention. It sounds like you guys already have. As soon as I heard results may vary. I love the fact they said your loss, if any, will vary. Which means you might not even lose weight. You might gain weight in some way. So,
And the commitment they have to this guy now to make sure that he doesn't go back.
oh yeah. I'm sure they're hovering over him. Yeah, hovering. Well, armed guards outside his house. Walk now! I want to drive. Walk! Yeah. Poor Jared. Anyway, let's go back to when you guys guessed my weight. When you guys, no, height. We did weight already. We did. Well, you guys did a pretty good job on my weight. We never finished the height data though. So I had to move your data around in my TI. Let me see where it is now. I think mine's in L3 and L4. Is that the same data you guys have? Yours should be in L5 and L6 though. Yours should be in L5 and L6. I had to put L5 and L6 from the other class in there. Here's what they guessed. So fairly consistent with you guys actually. Fairly consistent with you guys. Most 71s. Most 71s. Okay. So let's real quick get an image of your guys' data. So I want to see a histogram and a box plot. And we're going to work on identifying if anybody guessed either I was too short or too tall. And I say too short or too tall with quote marks in the air. Quote marks in the air because these are all just definitions of two and two, T-O-O, that we have made to quantify these outlier ideas. And we'll summarize on the board here momentarily. So I'm going to go ahead and plot. Yeah. You guys do 5 and 6, I'll do 3 and 4. So I'm going to turn the histogram on, plot 1. And I'm going to turn the box plot on in plot 2. 3 and L4. Okay, so plot 2. And let me just double check, make sure I did this right. I got plot 1 turned. Nope, it's not right. I got L3 and L2. That's wrong. L3, L4. And what's nice is you can look right here from the main plot screen. You can make sure that histogram, box plot, L3, L4. Except my plot's not turned on, so I'm glad I'm looking at this. So turn you on. There we go. Now we're solid. I'm gonna go zoom stat. There he is. I'm gonna finagle. I think we got as far as finagling last time. I don't think we went any further than finagling. So I'm going to finagle. I'm going to, oh, I got something else graphing. Hang on. Get out of there. And yeah, so that's, yeah. Scales at 1. I got no problem with that. What was your guys' highest? Somebody guessed 73? Is that right? Yes, somebody did. So I'm going to leave that exactly as it is and just bump up the Y max to 15. There, I can live with that. So here's our data. Here's our data. Nope, we got a big gap between 68 and 71. So there's our. You guys get the same image?
Yep.
Box and whisker looks a little weird. I think we mentioned this last time. Remember that, Jenny? Yeah. Box and whisker looks a little weird. What was missing? Remember the box and whisker plot from last time? Jen, our median is missing, but is it missing?
No, it's the same as the others.
Nice. It's on the quartile. It's just sitting right. There should be a median between the quartiles, but when you have so few data points and so many of you picked the same thing, the quartile and the median can be the same value. Sometimes you don't have whiskers. Like suppose everybody in here, let's not say everybody, suppose 10 of you said I was 5'8". There wouldn't be a bottom whisker then, because the whisker and the quartile would be 5'8", so you wouldn't even have a whisker on the bottom. So it happens. And you can see that by tracing, just like Jen said. 68 inches was the smallest guess, 71 was the 25th percentile, so a quarter of you guessed below 71, but 50% of you actually guessed below 71. That's what that's saying. And then your third quartile's out here, 72, and then 73. Small data sets have all kinds of weird, goofy stuff kind of occurring. Love it. So, on average, what did you guess? Should we use the average in this case before you even start calculating? Oh, what the hell? Go ahead and calculate. And then we'll talk about whether we should even use the average. So L3, L4. grab a marker. You guys get 71.2, so we'll call it 71 inches. Actually, my height's pretty close to 5'11 and a half. That's not bad. I mean, you guys pretty much targeted my height there too. So for my height, let's go over here on the board. So guess Sean's height. Your average guess is about 71 inches, and you've got a plus or minus around that 71 of about 1.5 inches. Should we use the average? What do you guys think? Should we use the average? What's your gut? When do you think it's okay to use an average, say, versus a median? The median's down a little bit lower, which is pretty close to it. Yeah, your median's also 71, so it's, when's it okay? Or conversely, when do you think you shouldn't use an average?
It's okay when we have several samples, so we are sharing between them equally. And, yeah.
Several samples, you mean like many data points in the sample?
Yes.
Okay. When could the average be misleading?
When the shape is like bell-shaped or something, we got skewed.
That, right there. When you've got skew in your data, that's when maybe you shouldn't use an average. Why? Again, remind me why again an average can be misleading? Good, Mimi. It chases the outliers. So I don't even know if there are outliers in this data set right now. But if there are any, the average could be chasing them. But looking at the median and the mean both being close to 71, my gut feeling is that there might not be any extremely large outliers. So looking at the data, this is why I like the graphic. Looking at that data, what do you think? Bell enough? Your call. Bell. Who says yes? This data is Bell enough. Nobody says yes. Jenny says yes. Jenny says yes. Haley says kinda. Jada says I'd like to see more data. Robin says I need some more coffee.
Yeah.
Yes. So we've got lots of ideas. So let's do this. Let's use this beautiful data set, no matter small though it might be, to motivate two ideas. First of all, let's calculate. Let's say yes, it is Bell enough. It's Bell enough. Let's calculate the outliers using the It's Bell Enough data set outlier formula. Remember what that is? Actually, you already know it. So let's calculate. Let's find, if any, outliers. Method number one, we learned it yesterday. Actually, I shouldn't say we learned it. We learned it many weeks ago. We used it yesterday. What was the method we discussed yesterday? Learned weeks ago, but we've used it in a different way as of yesterday. Go ahead, Haley, be brave.
Standard deviation.
What about it? Tell me more, my friend.
If too high of a guess would be bigger than the standard deviation.
How many?
2.
Good. That's okay. And I say that not like there's a concrete answer, but that's what's used in industry, in journals, in research.
Yeah.
Anything outside of 2 standard deviations or 95% of the data, the 95% central is considered typical. So basically, any outliers or atypical data will fall outside of 2 standard deviations, x bar plus or minus 2s. So all we've got to do is crunch x bar plus or minus 2s. And once we have x bar plus or minus 2s, we've got ourselves a range of typical. That's typical. Anything above or below that is too big or too small, just like Haley said. Did you guys have any luck a couple quizzes ago using the variable buttons on the TI to get x bar plus or minus 2s? Anybody give that a shot? Jenny's like, yeah, I tried it, but
I think I did it.
Gave it a whirl. I'll go through it just because it's nice. It takes away the rounding error, if there is any rounding error. When you can repeatedly round values when you're doing like nested calculations, repeatedly rounding introduces kind of bias error. So what's nice about leaving the values in your TI unrounded is you can round at the very end and kind of minimize that error. So I'll go through this kind of quickly. I'll talk the button pushes while we're doing it. But realize that from 2 quizzes ago, these button pushes are all on that quiz for reference. So let's go back to here. So I'm going to press bars, statistics. So I press the bars button, then 5. And what's nice about this menu is you have all the variables that you need. You've got x bar and s in 2 and 3. So you press 2. That gives you x bar out on the home screen. Now, it says x bar, but the TI is thinking of the value of x bar, so that's 71.2. Plus, now you see how s of x is 1.52, blah, 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 blah. We rounded it off to 1.5, But if you just simply type 2, then bars, statistics 5, S, x bar plus 2s, that will actually do the math for you. So when you press enter, this tells us if anybody guessed above 74 and a quarter inches, then you guessed too high to be a typical guess. Did anybody guess that high? No, the highest guess was 73. So therefore, nothing in that range, according to this rule. I can't emphasize that enough. Nothing's too big.
So there's no outliers.
There's no big outliers.
No big
Let's check for small ones too, right? Because remember, what you're essentially doing with this rule, Haley, very good question, by the way. What you're essentially doing with this rule is you've said, here, let me throw the camera over here so you guys can have this if you need it. You've said that your data is bell-shaped enough. You've said your data is bell-shaped enough. So what you've said is the data that falls in here is typical. The ones that are out here are unusual. And I'm putting that in quotes. Everything's in quotes. These are all human-made definitions. So what we just checked, Haley, we checked to see if there's any out here.
Right.
None out there. Now let's check to see if there's any down here. And all you got to do to check what's down there is do what up there?
Change it to minus.
Exactly. And this is the beauty of changing it to minus. Second enter, and then just edit in and change it to a minus sign. And then press enter again. So anybody that guessed below 68.15 or 0.16 would have a guess that's too low. And there was one of those, or two of those, weren't there?
What was the lowest?
I think it was 68, which snuck in right below that, didn't it? Snuck in right below 68.15. So we would term those just into the outlier range. So therefore, whoever said 68, your guess by this definition of outlier was a little too low to be typical, to be a typical guess. What does that mean? More on that momentarily. The meaning of outliers is important too. But as far as identifying them right now, that's all I want to look at is identifying them right now. Cool? Now, when I asked, is the data bell-shaped enough? Only one person was like, yeah, it is. And then once one person said yeah, somebody else said yeah. And then Haley was like, kind of ish. Because not all data is bell-shaped. As Elena pointed out, you can have skew. And you might look at that data and say, I think it's a little too skewed. I don't think it's bell-shaped enough. I think we got this goofy tail. And granted, it's a very small data set. But even if you filled it in, maybe it would look more like this, which would mean it's kind of to the right, it's less skewed, kind of leaning to the right. So what do you do if you have skewed data versus bell-shaped data? Well, there's a number of things you can do. I don't want to do a number of things. I want to get like one thing. So for bell-shaped data, this works beautifully. If you don't have bell-shaped data, I want to turn this bad boy off. And I want to motivate this next method. This is actually what your TI does when you run your modified box plot. So kind of like, this way you know what your machine's actually doing as it's crunching its numbers. So if you have bell-shaped data, yay, we like this. Typicals within 2 standard deviations. But what if you don't? Now, the beautiful part about this method is that it'll work on any data set. Even if it's bell-shaped, you can choose to run this method. A lot of students do run this method only because your TI does it for you automatically. And I like to call it the IQR method. So what I'm going to do is, I'm going to slap the graph down. I'm not going to slap anything. I'm going to put the graph down.
So this is for skewed data?
It's actually for any data, Haley.
Okay.
But basically, it'll work for skewed. And remember how the mode, when you're trying to describe the center of a data set, the mode pretty much works for skewed, bimodal, whatever. This is kind of like the mode of outlier recognition. Okay. It'll work for any data set as well.
Okay.
So definitely for skewed, but also it'll work for bell-shaped data. I want to caveat that with something in about 10 minutes, but we'll to answer your question directly, yes.
Okay.
The first thing you want to do, we're going to go through a series of steps in order to figure this out. The first thing that you do is you find the interquartile range. And please understand, friends, we're going to start probability today, which is one of the most exciting parts of this course, because probability is governed by basically natural laws or mathematical laws. In other words, when we talk about like the chance of flipping heads, the chance of rolling a 6, the chance of getting a royal flush dealt to you, those things are immutable. They behave a certain way, and they always behave a certain way on average. What we're doing right here, these are human-created definitions. So when I say find the interquartile range, that isn't like gravity. It's not like when you drop something, it falls because gravity applies universally. Somebody made this term up just to give us a quantifiable measure, okay? So just realize that, kind of focus that away. That's what IQR stands for, is interquartile range. And the definition of it is it's how far Q3 is from Q1. It's how far Q3 is from Q1. So for our height data, it would be Q3 was 72, I think, right? I think. Let me double check that. I think Q3 was 70. Oops, something's up here.
Yeah.
Yep. And Q1 was 71. So it's 1 inch. What is that the distance of? It's the distance between Q3 and Q1. Remind me what Q3 and Q1 are again.
The 95%. No,
Careful.
75%.
Very nice, my friend.
Sorry.
75th percentile and the...
And the 25th.
Perfect. So that means what percentage of you guessed within that 1 inch? What percentage of you guessed within that 1 inch from 72 to 71? Half of you, right? The box represents half of you, the middle half. So if you want an analogy, the box, and this is just an analogy, not an equivalence. See the difference there? It's an analogy, not a perfect congruence. The box is kind of like a standard deviation-ish. Now, it's not completely correct to think of it that way, is it? Because one standard deviation on bell-shaped data is what percentage? For a bell-shaped data, one standard deviation is roughly 68, about 2/3. This is 50, so it's actually tighter in, but equivalently, it's kind of like that. Is that fair? So if you're looking for kind of an analogy between method 1 and method 2, so this is ish the standard deviation, so one standard deviation. Now, just like with this method, we doubled the standard deviation to go out 2 standard deviations. What you then do here is you apply a multiple to that number. And the one that's commonly used is 1.5. Okay, we'll come back to that in a second. So basically, you take 1.5 of those IQRs. So you take that width and multiply it, make it 50% bigger. So it goes out, if you will, 25% on each side, or 12.5, I guess, percent on each side. So you're going to have 1.5 times 1 inch, which will be 1.5 inches. This is essentially doing the same thing that standard deviation does, in that it makes that percentage, if you will, wider, it picks up more data points. So instead of sticking with just 1, you've gone to 2 here. Now, this 1.5 is also not universal. Okay, that could be 3, sometimes 2 is used. 1.5 is the most commonly used. Make sure you can see this. There we go. Yep, multiply the 1.5, right? Now, this is the part that is a little bit confusing, but I want you to understand what the machine is doing. You take that number, and you create a range of values. Remember how this is x bar plus or minus 2s? You do a similar thing, but this, and again, this is what human beings have created. So the typical values are between, okay, work with me here. This is going to look a little bit strange. Q1 minus 1.5 IQR up to Q3 plus 1.5 IQR. This is kind of the big deviation from this one. If you're trying to look for a perfect congruence, that's why I said there isn't a perfect congruence. A perfect congruence would say, okay, perfect congruence says average plus or minus 2 standard deviations. Corresponding over here, you would think to use the median. Median plus or minus this number, but that's not what gets done. What gets done is they start on the quartiles and they go up and down from the quartiles. So let's just numerically, let's take a look at that, numerically. So numerically, right now, Q1 was 71, correct? 71. 71 inches minus that 1.5 inches. Q3 was 72 inches plus the 1.5 inches. And then just knock that down, whatever it is. So that's gonna be 69.5 inches. 69.5 inches up to 73.5 inches. So essentially, go ahead, Robin, ask me that question.
74?
Well, 73.5, 72 plus 1.5.
Oh, sorry, I brought it wrong.
Don't you worry about it. This is the one and only time you'll ever calculate this manually. I just hate to have the TI show you stuff and you think it's magic. It's not magic. That's what it's doing.
So, coming back to the outliers.
Yes.
So 68 actually is not involved into 69.5.
So therefore, 68 is still too low by this definition, isn't it?
Yeah, so it means that we've got an outlier.
We have at least one outlier, don't we?
Yeah.
68 is too small. Did anybody say 69? Nobody said 69. But 69 would have been an outlier by this definition too. Although 69 would not have been an outlier by this definition. And they don't always agree with each other because they're built on two separate statistics. Haley, go.
So if your IQ or let's see.
Go ahead.
If it wasn't